Alright guys, so here's the video I promised you about going over the exam. So here is the exam, as you guys probably remember. I'm going to go over each one of the questions and I'm going to do them right here in front of you, and hopefully this will help make some sense of what was expected, right? So starting with the first question, it says the data provided for you in the file named acedata.dat. I know some people had problems with this, but hopefully I gave you a way to do it during the exam with the Excel table. But it contains information on weather tracking during hurricane season. The table is large, but an example of how it looks is shown below. So this right here, it went up to 2016, so I couldn't fill it all in for you, but I gave you the columns, right? And that's the important part of what each column represented. And then it says, using the example table provided and the data file, complete the following. Import the data into MATLAB. Create individual variables containing all the data from each column, so years, ACE, tropical storms, hurricanes, major hurricanes, and then find the maximum and mean values for each of the columns. So that is the first thing we are going to do. So the first thing we have to do is load the file, right? And I know some people had problems with this, but it is, if I have it here, ACE underscore data. .dat. Let's see if that worked. That's right. I gotta do exam video 1. Let's try that. So I have loaded it right here. So as you guys can see, we have 1950 all the way to 2016, and there's a bunch of data in here, right? So just to see that it has loaded, we do have it. So that's the first thing we did. Now what we have to do is we have to create variables that house each one of the columns that we want, right? So essentially what I mean is that we have to create variables that are year, ACE, tropical storms, hurricanes, major hurricanes, and it has to house all the data in each of those columns. So we're going to obviously start with the year first. So let's do year. So year is equal to ACE underscore data, and we want, I think that's what we want. I'm pretty sure it is, oh no, it's that. So we want all the rows in the first column is what it is saying here. So all rows, first column. And so if we run this, I'm just going to do it just to show you, but if you run it, you get year, and it has 1950 all the way through 2016, right? So you're going to do that for each one of the variables. So I'm not going to, narrate this one super heavily, but the next one is ACE. We'll just call it ACE. ACE is equal to ACE data, and what we want is everything in the second column, right? And then we want, I'm just going to call this one, I think this one I did TS for tropical storms. So TS is equal to ACE data once again, third, all the things in all the rows, third column, right? And then we want hurricanes, so I'll just type out hurricanes, is equal to ACE underscore data times, and then we do this, and the fourth one, and then the last one is major H. So major hurricanes is ACE underscore data, and then we do this, comma, 5, and that should be the last of it, right? And I'm going to go ahead and run this, and we should have all the variables. So we have ACE data, ACE, hurricanes, major hurricanes, tropical storms, and the year, all in 67 by 1. So that's one column that has every one of these data points in it. And so now that we have that, it's pretty easy to do the next thing, right? We need to find the average, and we need to find the maximum for each one of these. So we have to create a new variable. Pretty straightforward. We do, although average year doesn't really help. I mean, average year is kind of a dumb thing to do, but all the other ones are fine, right? Because average year doesn't really matter. But average ACE value, average number of hurricanes, average number of tropical storms are fine. So let's go ahead and start with average ACE. So let's just do that one. So we have, we'll call it mean ACE. So mean ACE is equal to mean, and you just type ACE there. So it's going to use the mean function, which is a built-in MATLAB function, on the value of ACE. Then we have mean underscore TS, which is the mean number of tropical storms, is equal to mean TS. And then we do mean underscore that's what I'm going to call it, is equal to mean hurricanes. And then the last one, mean underscore major h, which is equal to mean major h, right? And so by running all of these, I'll just go ahead and do it so we get values here. So the mean ACE value is 97.97, mean number of tropical storms is 10.5, mean hurricanes is 6, and the mean major hurricanes is 2.58 or 2.5821. And so what that did is just like it said, it just grabbed the mean value, it grabbed all the values in the columns, and it just added them together and divided by the number, right? And then the last one, once again, very straightforward. Now that we have this, though, I'll go ahead and put these there. Then the last one was to do the max, right? So max underscore ACE is equal to max ACE, right? Then you do max underscore hurricanes, or TS, that's right, is equal to max TS. And then we do max underscore hur is equal to max hurricanes, right? And then we do max underscore, what is it now? Major hurricanes, major H is equal to max major H, that's right. So it's going to take all the variables again. I'm going to get rid of this so it shows. So we have max value of the ACE, max value of tropical storms, max value of hurricanes, and the max value of major hurricanes, and it should run. And so the maximum value of tropical storms in a year was 28, the maximum value of hurricanes in a year was 15, and the maximum value of major hurricanes was 8. And you can actually go look at this. So if you go to major hurricanes, it looks like the maximum value was the very first value. It was 8, right? The very first value was that. And then if we go look at maximum number of hurricanes, we can go look at that too. So hurricanes, it said it was 15. It is right here, and it would be in the 56 cell downward. And so if you subtract off, so that would be 2016, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5. So what, 2005, thereabouts? So that was the first question. All it was asking for was you to find this data and save it in variables. So not too difficult. Most people after the exam said that this one was pretty straightforward for them. So congrats to you. Now we move into the second question. I wish I had like the Who Wants to Be a Millionaire sound here. Dun-dun-dun-dun. So then we move into the next one, right? I'm going to go ahead and clear the window, and let's move in here. So the second question was, a rocket is launched vertically at t equals 0. The rocket's engine shut down, so at t equals 0, the rocket's engine shuts down. At that time, the rocket has reached an altitude of 500 meters and is rising at 125 meters per second. Gravity then takes over. The height of the rocket as a function of time is the following. It is negative 9.8 over 2 times t squared plus 125t plus 500. So this right here, for anyone that did not know, is a pretty straightforward projectile motion, right? You can actually see in the equation these values that were listed, right? 125 meters per second is the very first, is 125 times time, which is the first dimension of like position, right? The first derivative. So you get 125t, which is the starting velocity. And then you have 500, which is the starting height, which is 500 meters right here. So fairly straightforward things you can see right in the equation. So the first thing is to create a function called height that accepts time as an input and returns the height of the rocket. Call your function in your solution to part B. Remember, for this function to work, it must be created in another code window and saved as the exact same name of the function. Plot height versus times. For 0 to 30 seconds, use an increment of 1 second in your time vector. So this one, there's going to be 2 windows here, so I probably should go ahead and do that. So 2 windows here. The first one is going to be our function window. So we need to create a function here, straightforward. We have to do function output, which is the very beginning of creating a function that we learned. So function output, and this is the name of the function, not what the function's actually doing. This is the name. And so the name of the function we are going to call height. And we're going to call height of t, right? And then we have to do output. is equal to. So this is what the function is actually going to do. So output is equal to negative 9.8. I gotta make sure I do this one right here. 9.8 over 2. I'll put it on the other screen, so apologies for that, so I can get this right. So negative 9.8 over 2. I like to do this stuff by itself. It always makes me worried that it's going to mess up. Now it's times, but it's not just times though, it's dot multiply, because we're going to be using a time vector in the second part. Times t squared, right? Plus 125 dot multiply t, right? And then plus 500 for the last one. So let's see if this was fine. I gotta say this is height. Yeah. Let's see what it was. So what did I do incorrectly here? It must be that. I wonder if that's it. Error in the line, error in height, output. What did I do here? Okay, so we'll go take a look at it in just a second. I'm going to call it over here. So we're going to do time is equal to 0, going up by 1, going to 30, right? So 0, 1 to 30 is our increments, and we're starting at 0, going to 30, up by 1. Then we're going to do our height, which is the rocket height. I'm making a new variable here because the new variable is going to be used inside of the function that we did before. So it's going to be our height is equal to height of time, which is that first variable I created up there. So time is going to go into the height function. It is going to do that for every single one of the elements inside of it. And then it said plot height versus time for times 0 to 30 seconds using an increment of 1. So we have to then do plot time versus our height. And then we have X label. You will call this one, I think it'll be time then, right? Yeah, it'll be time. X label, time, seconds. Y label, height, I guess meters. I think that's what it is. So let's see if this works. Exam video 2 then. Okay, so I probably should have just done that. Okay, so it did work. So yeah, I should have put, so just for further reference, this is why you do these things right here, because you get a bunch of stuff here. So right here, you have gotten the graph out, right? So the graph here makes sense to, it should make sense to you, right? And the reason why it should make sense is because, oh wait a minute, X label, time, seconds. Incorrect number of input arguments. What did I do here? I wonder if this is, oh, I wonder if it's supposed to be a string. Height, meters. I think that's what it's supposed to be. I must have forgotten the string there. Let's see if that works. Yeah, so that works. So I forgot the string. So these single quotes made it a string variable to save it as a characters. So we have height in meters, and we have time in seconds. So the reason why this should make sense to you is because if you read the question, this right here would have given it all away if you did it wrong. Because if you remember from the question, it had an initial height of 500. Right here, the height at time equals 0 is y is 500, which is 500, right? So that right there would have easily given it away for you if something was wrong, right? And so that makes sense. We have a projectile motion curve. This is what it should look like, right? So it just looks like this and goes all the way down. At time is 30 seconds, essentially. You are still a little bit off the ground, though. Or no, y is equal to negative 160, so actually we are below the ground. So essentially when when height equals 0 is when we hit the ground, which I don't know when that is, but you could trace the graph and find out. But this is all I expected of you. I expected this function and this set of code, and you get these answers out. All right, and then we have the last question. The last question, I'll pull it up again, is right here. And it says, create an input script that queries the user for the following information and displays it on the screen in the following sentence. The inputs are name, age, hometown, and your favorite sport. And then right here I gave you an example. So it's my name is blank, and I am blank years old. I am from blank, and my favorite sport is blank, right? For example, my output would read as follows. My name is Jared. I'm 26 years old. I know I'm old, right? I'm from Decatur, Illinois, and my favorite sport is mixed martial arts. So for the output sends, use the fprintf command. So I even told you what command you should use here, right? So let's go in here. So in here, we now need to go, let me pull something up. Oh, that wasn't what I wanted to do. Missed the wrong thing. I gotta get rid of that as well. Apologies for that. So in here, we then need to start off our thing, right? So we need to start taking some information from the user. So the information from the user is very simply going to be like your age, your hometown, your name, those type of things, right? So how we should start is how we have done it in other parts, right? So we have to do, let's start with name. So name is equal to input, and then we do a character string here. You do enter, or what is your name? However you want to do this one is fine, but you can get it to accept it as a string here. And so if you put this comma and then you do single quotes around the S, you don't have to put single quotes in around your answer whenever you input it. So that's just something that you could have done. So now we have the first one, but that's only for strings, right? It's not for numbers. So let's do age. So age is equal to input. What is your age, right? And then we do hometown. So let's do hometown. It's equal to input. Where are you from? Let's try that. Where are you from? And then favorite sport. So sport. Let's try that. So we do input. What is your favorite sport? Right? Everybody likes a sport, maybe. So those are the inputs that I needed you to have, right? Pretty simple, pretty straightforward. These are the ones that we needed. Does that make sense? I hope it does. So now that we have that, we need to have the fprintf, right? We just need to print in the type of things that we want. So we need to do fprintf. Fprintf that, not equals. Fprintf, and then we have to put in that sentence. So how you would put it in, let me go ahead and get rid of this. So fprintf, we would do my name is, and then right here you would put your variable, right? Your very first variable, which is name. But you want to put it in the total string character. You do not want to do, you have to use the right thing here, the right, type field format is what it's specifically called, but your right symbolism. So what you should have put here is %s. My name is %s, and I am, this one should have been %f. So I am %f years old, okay? So what these are doing is these are just taking the place. These are variables, right? Essentially, these are just variables, but it's going to be what you put in, what you define in just a second. I am from, this one you want %s again, which is your hometown, and my favorite sport is %f again, or %s again. So for numbers, you can use %s or %f. %f is fixed point notation. You can also change the number of this. Remember, it doesn't really matter. You can change the number of decimals that show by using this. So I could have done this right here. So %f, I could have done, let's say 3 and then 0, right? So what this will do is it will display 0, 3. It will display 3 numbers before the decimal and 0 afterward. Since my age is you know, a whole number, right? Should be good, right? Should no problems there. So, oh wait a minute, I did that backwards, didn't I? It's supposed to be on the inside. Yes. So be careful here. I could have made that mistake there. So I'm gonna say 3.0. Sorry, I was sitting here. I was like, man, that doesn't look right. It's the backwards. Sorry, dyslexic moment. So it says I am from %s and my favorite sport is %s, right? So we have this all straightened up. Now you close the single quotes, and by closing it, now this is where you enter your variable names, right? So your first one should be name, second one age, third one hometown, and the last one should be sport. So this is rather long, but we'll see how that works. Exam video 3. So this is where we tested if it works, right? So what is your name? I'm going to do Jared. So it gives me that, right? What is your age? 26. Where are you from? Decatur. What is your favorite sport? MMA. And I'll just type out the whole thing. Mixed martial arts. Sure. So right here, my name is Jared, and I am 26 years old. I am from Decatur, and my favorite sport is mixed martial arts, which is all the things that I put in up here, right? And they were saved. And if you notice, 26 years old, because I'd specified 3 before, so if this would have been good up until I was 100. If I was 1,000 years old, it wouldn't show all of them, right? But I'm not ever going to make it that far, I'm pretty sure. And then it didn't show any after the decimal point because I just, like I said, everybody's whole numbers are age, so essentially I don't need to show any decimals. And then I am from blank, I'm %s, which is Decatur, which is my hometown, the third saved variable, and then my favorite sport is mixed martial arts, which is the third, last one. So this is what I expected from you. If you have any of these, so let's go kind of recap here. If you have most of this stuff correct, you'll do just fine on the exam. Obviously, the 100% will be the one that has everything right. But if you have the main structure correct, and maybe you just, I don't know, missed a semicolon or missed a colon or something like that, don't expect to do poorly. You will do fine. I know debugging code takes a long time. I've spent many hours debugging code a long time ago for a coding class, and so sometimes it doesn't come to you right away. Probably in this video you've seen me make like 2 or 3 mistakes, but I caught them. But sometimes you don't. Sometimes it takes a while, and I know an exam isn't a good time to be debugging code, which is why you have to grade it based on what the actual content is rather than the result. So if you have most of this stuff, you will be fine. But that's pretty much it for the video. I hope this cleared things up a little bit for you. If you have any questions, feel free to send them to me.